Hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing strings topic and the pattern was sliding window. Today we will do the second question from this pattern, which is longest substring without repeating characters. So let's read the problem statement. It says we'll be given a string S and we have to find the length of the longest substring, okay, without duplicate characters. So you know what is substring? Continuous part of string, and out of all such substring we have to find the longest substring where every characters are unique. Means without duplicate character means every character must be unique. As you can see, example number 1, A, B, C. Till here we have unique characters. Once we pick another A, then A will become duplicate, and hence this is not a valid substring. So in this case you will find only 3 length of longest substring which has unique characters in it. So let's see the constraint. The constraint says S length can be 0 also. Obviously if it is 0 means the longest length of substring is 0 itself, and it can go till 5 into 10 power 4. Okay, why we read the constraint? Because it helps us to optimize our code and identify which pattern to apply when we want to optimize. So let's come on to the screen. Here is our string given, and this is a string, and we know what are the different substrings in it. So if we are starting our I pointer from here, I is equal to 0, it means, can I say I want every such substring which starts with this ith index. So what are all those substrings? Can I say A, B, A, B, C, A, B, C, A, and so on till A, B, C, A, B, C, B, B, correct? Similarly, when next time I'll move my I at first location, I can say I want every substring which starts with I is equal to 1, means first time B, next time BC, BCA, BCAB, BCABC, and so on till last. Similarly, for the next time again I'll move this I at here C, correct? And now we'll see all the substring which starts with this I is equal to 2, means C, CA, CAB, CABC, and so on. So basically here also we have to generate the substring, but not till last index. We have to generate the substring until we don't found any duplicate character. Means in this case, suppose my I is at 0 index, okay, I is at 0. So of course I have to start my jth index also to keep a track of all such substring, okay. So when I is at 0, I'll start my J will say, okay, I have from I to J, means from 0 index to 0 index, which is nothing but A itself. Next time when J will move to next index, it will pick A also and B, it will pick B also, so together it will become AB. Next time we'll move this J at C, correct? And now total substring will become ABC. Till now this is also valid. Now next time when we'll move this J at this index, we can see that this A is already present earlier, correct? So hence this 4 length substring cannot be my valid substring as per the definition, because duplicate character found. So how to keep a track of duplicate found? Means we should store our character somewhere na, to keep track, okay, this character we already found earlier, so no more character needed. Yes. So what do you think, how can we keep a track of? We can either put in map or we can either put in set, correct? Because if you'll put that A, B, C in map or set, like hash map or hash set, so for next time when I'll find this A, definitely I can check in my set or map ki if this A is already present, means to stop. Means stop for what? I was at 0, so I was looking for all substrings starting with I is equal to 0, so I looked for A, B, C. But if I'll go ahead, I'll find duplicate, so I have to stop for I is equal to 0 substring. So means once duplicate found, I have to stop for I is equal to 0, and next time I am free to move my I at 1. Now again I want to look for all such substring which has unique characters from this ith location. So I'll start, like initialize my J from I. Now I'll see B, okay, unique, BC unique, BCA unique. Now BCAB, no, it's not unique because B is already there in my map. Okay, so here's the trick. If at first you will put this A, B, C in map, okay, once you found A, of course you will break. But don't you think, because anyhow you have to move ahead, correct? As this B found, which B is already present, so hence again we have to stop, but stop for what? I is equal to 1 index. Okay, so till now we have found only 3 length maximum substring which has unique character, and first we found with ABC. Okay, anyhow we have to return the length, so it does not matter. Now next time we'll move our I is equal to 2. Again we'll start our J from here, C unique, CA unique, CAB unique, but C, this C and this C are duplicate, we have to stop. So again with I is equal to 2 we have found 3 length unique substring, correct? So hence we can say ki till now only 3 maximum. Now again I'll move this I at 3. So what I am actually doing, and till where I can move my I can say till last index, correct? Yes, because here the size is not fixed, size is variable, so hence we are free to move our I index till here. Okay, and with the help of J index we can keep a track of longest substring without repeating character. Okay, so with this approach, if you understood, definitely we can write this in for loop ki for, like for int I index we want to start from 0 and I less than s dot length, yes, okay, and I plus plus. Now I want the substring from ith location, so I have to start my J also, correct, int J, but I will start from ith index, correct, and J till less than length plus plus. Now you will say ki we have to stop, then why we are running till s dot length? In the condition we'll add ki if the index character already found, then we'll break that for loop. Anyhow it is same, correct? Okay, so to break the for loop, the condition was ki if that character found in map or set. So definitely we have to create also, and remember all the set will be unique for every ith index. So hence we have to initialize the set somewhere here. So we will initialize our set, correct, of character type name set is equal to new hash set. Now one by one I have to read this, like read the characters with the help of J, that will save in char C is equal to s dot char at J. Okay, one by one we will read character, we will store this, and here we have to check ki if this set dot contains, like if the set contains what, this character C, so we can say duplicate found, so hence we have to break. So this inner for loop which is running for J, basically that will break here. Otherwise our task is to add in the set, so we'll add the character in the set, correct, and as we have to keep a track of maximum length, remember we have to give the maximum length of that valid substring, so for that we will initialize our max answer somewhere here with 0, and after adding this here we will check ki what is the maximum answer till now. So math dot max, this like previous max answer is maximum, or else this current length. How can we keep a track of current length? Basically my I is here, correct, and J is here, so when J is here obviously everything is valid. Okay, so what is the length? J minus I plus 1, correct? Okay, so that is my maximum length, so that's what I'll like check here or update here, J minus I plus 1. Now the next time when I was here and J will hit this what, duplicate case, anyhow this length is not valid, so that's why when we are finding this character already present in the set, then and there we will break it, and anyhow that length was not valid. So before that when J was one location behind, then the condition was true, and hence we already saved in our maximum length or maximum answer, and after coming out of these two for loops we can simply return our max answer. So what is the time complexity for this? Definitely if you see, the first for loop is running for like I from 0 to length. Okay, so definitely this is going to take O of n time complexity, and the inner for loop we are running for every I, like J starting from ith location and going till last. Okay, you can say keep duplicate found, then so we are stopping, but what if in the worst case like all characters are unique? Okay, so you can think of that way ki all characters are unique, so it can be at max 26 character. So in the worst case also you will find ki J is only running for at max 26, correct, because from next time again whatever the character will find in this previous 26 length, it will be a part of some duplicate, correct, so hence we are going to break that. So O of n for this, to be more precise I am saying this like without seeing, anyone can say ki yes this is also O of n, so total O of n square, correct. So n was 5 into 10 power 4, so n square will become 25 into 10 power 8, and this will definitely give you TLE. Okay, but if you see this more closely, because this is string, so always think of whenever it is we're talking about string and whenever we are iterating on strings and characters, you know, unique characters we are iterating for, and characters are what, 26. So hence in the worst case also this inner loop will run for 26. So here you can see whatever discussed, we'll like initialize the length and initialize the max length or max answer variable to store our answer. First for loop will run from I 0 to n. We'll initialize the set and we'll run this j loop from I to n. Okay, now we'll read the character one by one and we'll check in the set. If it is present, we'll break, or else we'll add in set and update the maximum length. This we can run. Now we can submit this as well. As you can see, it has been submitted. Time complexity was n square, 26 cross n. Okay, but can we reduce this further? Like, as you can see, it is very slow because we are somehow like doing this in a brute force approach only. Okay, can we reduce this? If you see like why we need to reduce, first question is why, because anyhow the time complexity is 26 into n only, linear only, right? Then why we need to optimize it further? Wherever you see the repetition, you can think of optimizing there, but how we are seeing this repetition here? If you see the first ABC, okay, for this first window we already knew that all these characters are unique, correct? Once you found this A, you thought okay, this is my final answer, and now again restart from this B location. But don't you think again you will check B, again you will check C, which you already checked that these were unique only? Then why to check it again? I hope you understood. Okay, so this much part, which is nothing but whatever the length you found minus 1. So hence we are checking this B and C are unique or not again, that we already have checked earlier. So this is called repetition, and that's how we do using the sliding window approach, because in string we have learned two patterns, 2 pointer and sliding window. We cannot apply 2 pointer here because 2 pointer we apply whenever we want only two such characters to compare or do some manipulation, but only with that exact two characters. Here we want a substring, like continuous part, correct? So hence we can think of sliding window, and you know the sliding window approach actually reduces our time complexity from O of n square to O of n. Basically it will reduce the repetition task. That's enough for me. Means in the brute force we saw it was taking 26 into n, means 26 O of 26n. Let's see how can we reduce by using sliding window. We will initialize the left pointer from here and right pointer also from here, like at the same point. Okay, and now basically we have to keep a track now, like all characters are unique or not. So hence we can store this in map. Okay, in map, hash map. So in map we'll say we found A and its frequency is 1, that's what we save. But as per right index, remember, not with the help of L. The rule is very simple in the sliding window. Right always expands, okay, and left always shrinks. So whenever we are expanding, we will add that character in the map with the frequency count, and whenever we are shrinking, we will remove that character present at L index and reduce the frequency. Basically reduce the frequency, and whenever the after reducing the frequency this will become 0, then only we remove from the map. The simple idea. So we added A here, okay, and frequency 1. Now next time we'll move this R index at B. Again we'll check if this is already there in the map or not. No, it is not there, means we have found unique character. So hence again this B we will add this with frequency 1. Now again we'll move this R index ahead at C. Again we saw that C is also not there in the map, so unique character found, so we'll add this in the map. Okay, now we have to move this R pointer ahead. Now this character, when we check in the map, you know, to check or to read the character is present or not in map, it takes O of 1 time complexity in the best case or average case, not in the worst case. I hope you know the reason behind it. So it will take O of n, let's suppose. So A is already there, so hence this much is not a valid length. So can I say, like, whenever we want, like if we know right and left index are valid, to calculate the length, what we do? Right minus left plus 1, correct? But we know this rightmost index is not valid, and I want to calculate this much length because I know till here it was valid, correct? So I can say ki right minus left instead of plus 1, only right minus left is my valid length. So this we will update in our maximum answer. This much to clear. But how to move now? Because instead of using 2 for loops, we are actually doing this in 1 for loop. That's what sliding window does. So once found the duplicate character, but we have to move forward, correct, to find the next longest substring. So now expansion phase done. Now shrinking phase will start. So L will start moving ahead by reducing the frequency from the map, correct, and deleting if the frequency becomes 0. Very simple. So we'll see ki what was a character denoted by L. So it says it was A. So we'll reduce the frequency, whatever it was, by 1, and it will become 0. As it has become 0, so our task is to delete this, okay, and we'll move this left pointer ahead here, correct. Now so we can see ki yes, we have unique character, but how the code will know ki the character which we were looking to delete was A only. So hence we have to add this like left movement, means shrinking, in a while loop ki remove all character until the A gets removed, correct. Why? Because it might happen ki before this we had DE, okay, and left was here, left was here. So definitely D, when we will remove, still we have a duplicate character. E, when we will remove, still we have a duplicate character. So we have to keep on shrinking or keep on moving the left ahead until the A gets removed, okay. So that's why the shrinking phase we always add inside the while loop. So first, so we need a map, so we'll create a map here, and now we want a left and right pointer. So left pointer we can initialize here, and right pointer we will keep a track with the help of for loop itself. So we want to run from 0 to s dot length, correct, and r plus plus. Now with the r pointer we'll read the character C, means s dot char at r. Now after reading this, we'll put in the map ki map dot put, we want to put C, and we have to check the value. So map dot get or default value, because we don't know ki in the map this character is present or not. So we'll get the character frequency or else 0, and we'll initialize this. After adding it into a map, we have to check ki what if the frequency is greater than 1. Initially, so when we will add this A character, so frequency will be 1 only, correct. So hence anyhow the frequency won't be greater than 1, but to check that removal, like duplicate case, definitely the frequency will be greater. So while map dot get C frequency is greater, remember when our R is A, so this A frequency will become 2 na. So we have to remove, like we have to shrink towards the right side by left pointer until this A gets removed. So that's what we are checking. Until the frequency of this character in the map is greater than 1, we have to keep on shrinking. Now how we'll do the shrinking? We'll read the character called C left, okay, s dot char at left, like by the left pointer. So whatever is the character, here we see the character is A, that's what we want to reduce. So basically first we will reduce the frequency. So we'll do map dot put what? Frequency of this C left character, correct, and the frequency we want to reduce. So map dot get left C left, okay, and -1, we'll reduce the frequency. So now we have reduced this. Again in the same while loop we'll go and we'll check ki now the frequency has reduced to what? Is equal to 1. But the while loop case will not be true because it is not greater than 1. So hence we can think of ki yes, now after removing this left pointer ahead, the characters in this substring are unique. But we have to move this left also, so we have to do left plus plus here. And after coming out of this while loop, we can update our maximum length, which is answer math dot max of max length, and what is maximum? Right minus left plus 1 is maximum, correct. And after coming outside the for loop, we can simply return the maximum length here. So let's see the code. First we initialize the map, okay. In the map we'll save the character and frequency, we'll initialize the left variable and maximum length, we'll take care of the right variable with the help of for loop, and that one by one we'll read the character with the help of right pointer and we'll put in the map, okay. And forget about this line, we'll put in the map, and after that we'll check, like keep on tracking the maximum length also. And inside this what we are doing, this is a shrinking case, okay, the shrinking condition ki when we have to shrink, when the frequency will become more than 1, means 2 means it is duplicate. So once it is duplicate, first we have to shrink the left character value, like left index. So to move First we have to read the character, we have to reduce the frequency in the map, and then only we can do the left plus plus. Okay, so we can run this code, and if you want to know the time complexity, you can think of it is near around O of n, but it is not. How? Because see, first basically right pointer to you are running from 0 index to last index for sure. Okay, as you can see the code has been passed, but it is slightly slower. Why? Let's see. So okay, so first, so you are doing this key right will run for O of n, but if you see here, okay, you think of key is only running for one time, but let's take a condition, let's take a test case. Suppose the test case is A, B, C, D, E and again E, okay, F, G, H and so on. So obviously you will be at here, A is unique, B is unique, C is unique, D is unique, E is unique, and what is this? Again E, okay, E. So now when you are at E, your right pointer is at E, so you will keep on shrinking. So you will start moving your left pointer ahead until the frequency of E become 1 again, correct? Because now the frequency is 2. So this while loop will run for how much time? Do you think for one time? You are going to reduce this, correct? So basically you run for almost O of nearly n only, correct? So in the worst case, it can go to O of n square also. But why it is still a better case? Because here also if you see, and when right was here, you didn't shrink. Here also you didn't shrink. Here also you didn't shrink. Here also you didn't shrink, correct? So in this case, what was the time complexity? When your R was here, you did not shrink, okay? So while loop did not run. Here also 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 did not run. But here you ran for almost n only, correct? So only for one time, na? Or at max, suppose again you think ki F, G, H, I, J, again J, K, L and again L. So here also you will move your R, till here you will find all unique, but again when you hit this again another L, you will start shrinking your left pointer from here and you will go to till this, but only for one time or two time, okay? So it's not like n square, when it is n square, when for every index you are running again for n number of times, but here you are not doing so. So in total, either it looks like n square, but it is not. In total it takes O of n plus O of n, which is O of 2n. Okay, it is linear, but definitely it is optimized, but we can still optimize far better. Why and how? This while loop, can we think of reducing this while loop? Because O of n to for sure we need it, okay, but extra O of n gets added like plus, not multiplied. Remember, either it is nested, again I am saying this again and again, when you will dry run this, you will get to know ki either it looks like nested but it is not. So we want to reduce this into O of 1 so that our total time complexity will become O of n. Can we think of this? But before that, this was your Java code. I want to give you the Python and C++ code as well. Okay, here is your Python code. Similar approach, everything is same. Code is very small, as you can see. And here is your C++ code if you are from C++ background and if you understood the logic. Okay, again the time complexity is O of 2n. Okay. So now, how can we optimize it further in exactly O of n? If you see here, definitely our L and R will start from here, correct? Left pointer and right pointer, correct? Unique will move this right pointer ahead. Unique, move this. Unique, move this. Unique, move this. Unique, move this. Duplicate. Now we have to shrink, okay? So, earlier with the help of sliding window, you kept on, shrinking until you found this E again, okay? Don't you think in the map, instead of saving the frequency, what if for every character we would have saved the index, means position? Why? Because if we already know where my E character is present, why we are moving this left ahead? To find where is my E, correct? So what if in the map itself we'll save the index for E, okay? And once duplicate found, in the map we can go like before, don't put the position for the new E, no. Once we found that this E is already present, means in the frequency we have saved the previous location, correct? So instead of moving this left pointer one by one, why not to directly put this left pointer one location ahead of this? Because I know at that location E is there, so I'll put my E like left pointer directly at that location plus 1. So now going forward, my left will directly come from here to F. And now suppose A, B, C and so on, again my right will start moving, unique, 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 unique. So basically, don't you think what happened? Right is moving for one time, and when my right hit for this E, duplicate, instead of waiting for the while loop for left pointer to shrink for again n number of time, I directly switched in O of n from this position to F, O of 1 time complexity. So hence we reduce that while loop. So that's what we are doing here. We initialize a map, everything is same, we run the for loop, again we read the character with the help of right pointer, and we check if our map contains, okay. So we will directly move this left pointer where? Map.get, because if the ch is already there in the map, we want to read the frequency, correct? We want to read the frequency and we want to put one more pointer ahead. So we directly put the map like left pointer at one more pointer ahead. If it is not there, we'll simply put in the map what? We'll put the character with the index, and that index, current index, is pointing by right index. So hence we are putting right, and after every iteration we'll keep on adding, checking what is our maximum length till now, okay. And as you can see the time complexity, only we are running this for loop for n number of times, and now no more while loop, so no more 2n condition. So hence this code is the faster, and it takes only O of n, exactly O of n time complexity. And now we can submit, and then you will see this is the fastest code, as you can see. So remember, in the interview, don't forget to talk about brute force for sure, and before this solution now, always try to talk about the sliding window approach, okay, and say why it is taking 2n, because most of people gets confused and not able to explain why even it is nested, but still it takes 2n instead of n square. So this was a Java code, and here is a Python code with the same optimized O of n solution, and here is your C++ code with the same optimized O of n solution. So I hope you understood each and every step and each and every approach. With this we can go in our sheet and we can mark the second question done. So I hope you guys understood. If yes, do let me know in the comment section, and please do comment key understood or solved, or even if not understood, what was the point where you did not understood, do let me know. And if you like the video, please hit the like button and subscribe it if not yet subscribed. And if you feel all these pattern wise videos and playlist is helping you, or it can help your friend, then don't hesitate to recommend this channel to your friends as well. And that's it for this video. If in case you guys are new to this channel, we are following this pattern wise sheet. The link you can get from the description. And that's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.